The theoretical yield is the amount of product that would be produced if all of the limiting reactant reacted as expected. The actual yield is the amount of product that is actually obtained from a reaction. It's important to remember that the actual yield is always less than the theoretical yield. The theoretical yield and the actual yield allow us to calculate the percent yield, which is simply defined as the actual yield divided by the theoretical yield times 100%. Silicon carbide can be produced by reacting sand or silicon dioxide with powdered carbon at high temperature. In this process, carbon monoxide is also formed. In this example, we are asked to calculate the percent yield when 51.4 kilograms of silicon carbide is recovered from processing 100 kilograms of sand. We can see here that sand or silicon dioxide is the reactant and silicon carbide is our product. We can also see that the 51.4 kilograms of silicon carbide produced is the actual yield for our process. The strategy for solving this question is to start by balancing our chemical reaction. Next, we use the amount of reactant, 100 kilograms of silicon dioxide, to calculate the theoretical yield for our reaction. And this is used in conjunction with the actual yield, then to calculate the percent yield. Now, in order to calculate the theoretical and percent yields, we start with a mass of silicon dioxide, or sand, and use this to convert to the moles of silicon dioxide. This is then used to convert to moles of silicon carbide, which is our product, which is used to calculate the mass of silicon carbide, which is our theoretical yield. Our theoretical and actual yields are then used to calculate the percent yields. So starting with our balanced chemical reaction, we start with silicon dioxide plus carbon reacting to form silicon carbide plus carbon monoxide. Now we have to balance the reaction. We can see that there are 2 oxygens on the left and only 1 oxygen on the product side. So we add the stoichiometric coefficient 2 in front of our carbon monoxide. Next, we balance the carbons. On the product side, we have 1 plus 2 equals 3 carbons, and on the reactant side, we only have 1 carbon. So we add the stoichiometric coefficient of 3 in front of the carbon. Our reaction is now balanced. Now we calculate the theoretical yield, starting with 100 kilograms of silicon dioxide or sand. This converts to 100.0 times 10 to the 3 grams of silicon dioxide. Now to convert from mass of silicon dioxide to moles of silicon dioxide, we divide by the molar mass, which is 66.09 grams per mole of silicon dioxide. We can see here that by dividing by the molar mass, the grams of silicon dioxide cancel, leaving us with moles of silicon dioxide as we had intended. Next, we want to convert from moles of silicon dioxide, which is the reactant, to moles of product, silicon carbide. We can use the stoichiometric ratios for this, and we see here that from the balanced chemical reaction, 1 mole of silicon dioxide produces 1 mole of silicon carbide. So we multiply by 1 mole of silicon carbide and divide by 1 mole of silicon dioxide. In doing so, we see that the moles of silicon dioxide cancel, leaving us with moles of silicon carbide, as we had intended. Next, to convert from moles of silicon carbide to mass of silicon carbide, we multiply by the molar mass, which is 40.10 grams per mole. And we see that in doing so, the moles of silicon carbide cancel, leaving us with a mass of silicon carbide in grams. Plugging this into your calculator gives us 66.733 times 10 to the 3 grams. And converting this to kilograms gives us 66.733 kilograms of silicon carbide. The percent yield can now be calculated by taking the actual yield and dividing it by the theoretical yield and multiplying by 100%. The actual yield was given in the question as 51.4 kilograms, and the theoretical yield was calculated as 66.733 kilograms. Plugging this into your calculator gives us 77.02% as the percent yield. Now, since the smallest number of significant figures in our question is 3, we round our answer to 3 significant figures, giving us 77.0% as our percent yield. The last step here is to check our answer, and we see that since our percent yield is less than 100%, our answer seems reasonable.